Welcome to Fluid Coding and AI. Today we are building 3 real repo automations: issue triage, CI failure diagnosis, and documentation updates. The test is not whether an agent can write text. The test is whether the workflow becomes maintainable automation or just hides a brittle prompt behind GitHub Actions. The useful question is not, can an AI touch my repository? The useful question is, can I review what it is allowed to do before it runs and audit what it did after it finishes? For these 3 automations, the answer depends on boring controls: compiled, actions YAML, triggers, permissions, sandbox mode, network access, structured output, job logs, artifacts, threat detection output, timeouts, costs, and generated pull requests that a human can actually review. GitHub Actions is the control plane here. The compiled workflow, YAML, is the first artifact to inspect. It has jobs. Jobs run on runners, usually in parallel unless you connect them with dependencies. That matters because the agent is only one step inside a larger CI contract. The permissions block can reduce what the GitHub token can do. GitHub recommends least privilege, and the default token should stay read-only where possible. But there is a trap. Actions can access the GitHub token through context even when you did not explicitly pass it into the action. So the boundary has to be the job permissions, not wishful thinking. With the coding agent action, the safest mental model is simple. It installs a tool, receives a prompt or prompt file, runs inside the runner, and writes an output. For OpenAI Codex action, the documented inputs include prompt files, output schemas, model choice, reasoning effort, codex arguments, sandbox mode, and trigger allow lists. Its default sandbox is workspace. Write with read-only and danger, full access also supported. On Windows GitHub-hosted runners, the action documentation says the supported sandbox is not available, so the unsafe. The dangerous part is not only shell commands, it is also text. Agent workflows read issue titles, issue bodies, pull request comments, commit messages, repository instruction files, screenshots, and sometimes logs. Codex Action Security Guidance explicitly treats these as prompt injection inputs. GitHub Expression Expansion adds another layer. Untrusted values like branch names, issue titles, comments, and action inputs should not be interpolated directly into shell scripts. Pass them through environment variables and quote them. If the workflow cannot separate trusted instructions, the lowest risk automation is issue triage. Trigger it when an issue is opened, edited, reopened, or manually dispatched. Give the classification job read-only access unless it truly needs to apply labels or comments. If it does write to the issue, keep that as a separate step with issues write permission. The agent should return structured output, category, labels, confidence, missing information questions, risk, and whether it should comment. That turns triage from a confident inbox filter into a reviewable receipt. The model makes a recommendation before GitHub state changes. The second automation is CI failure diagnosis. Do not make the agent the judge. CI is still the judge. The agent's job is to gather the failing run, identify the failed job end step, read the relevant logs, form a root cause hypothesis, and propose a small fix. The output should include evidence lines, files to touch, a test command, confidence, and whether a human is needed. For permissions, split diagnosis from mutation. A read-only job can inspect actions and contents. A later write job can open a pull request only after the diagnosis artifact exists. The third automation is documentation update. This sounds safer than code, but it can still damage trust. A docs agent should not invent product semantics from a diff. It should update synchronized surfaces, README snippets, API references, configuration examples, changelog fragments, and docs pages that are tied to changed files. Use pull request path filters for code, schema, API, CLI, and docs-owned files. Require a docs build or link check before opening a generated pull request. The best docs PR explains what changed, what command validated it, and which sections it intentionally skipped. Logs and artifacts are what make this debuggable. GitHub exposes job and step logs, downloadable log archives, failed step expansion, and billable execution minutes. Artifacts can persist, build output, and pass data between jobs. Step summaries are useful, but they are not enforcement. GitHub caps a step summary at 1 MB, displays at most 20 summaries per job, and a summary upload failure does not fail the job. So keep the durable record in files and artifacts, agent inputs, structured outputs, logs, patches, test results, cost records, and security. Network access is another place where agent workflows either become serious CI or stay as vibes. The threat detection job is where that difference becomes visible. OpenAI's Codex security docs describe local defaults with no network access and workspace, limited rights, and cloud agent phases that are offline by default unless internet is enabled. GitHub Copilot Cloud Agent has a configurable firewall with organization and repository rules. For GitHub Actions runners, Step Security Hardened Runner can observe outbound calls, file integrity, and process activity, then move from audit mode to blocked allow lists. It maps network connections back. Cost control is not an accounting footnote. It is part of the security model. GitHub Actions costs are charged to the repository owner, and anyone with write access can run actions. Copilot Cloud Agent uses both Actions minutes and GitHub AI credits. GitHub defines one AI credit as 1 cent for business and enterprise usage. Based billing. OpenAI's published API pricing for GPT 5.3 Codex lists different prices for input, cached input, and output tokens. The Codex rate card maps the same model to credit costs. Benchmarks support caution, not blind delegation. OpenAI. A generated pull request is not the final proof. It is the review surface. The PR should say what input it used, what commands ran, what tests passed or failed, what files changed, what assumptions it made, and what it skipped. For a CI fix, the rerun matters more than the explanation. For docs, the build or link check matters more than a confident summary. GitHub Copilot's Cloud Agent is useful as a comparison point because it exposes session logs and makes work visible through commits and logs. Custom workflows should meet that bar, not hide behind a final comment. So the verdict is conditional. Agentic Repo workflows become maintainable automation when the agent is boxed into normal CI discipline, explicit triggers, least privilege permissions, no ambient secrets, sandboxed file system access, denied or allowlisted network access, structured output before mutation, separate read and write steps, durable artifacts, visible logs, human review, and hard runtime and cost limits. They become brittle prompt wrappers when the workflow grants contents right everywhere, lets arbitrary comments trigger expensive write, capable runs, treats the prompt as the only policy layer, exposes secrets or network access without receipts, and opens pull requests without validation. If this helped you judge agent workflows like real engineering systems, like the video and subscribe to Fluid Coding and AI. The next time an AI opens a pull request, check the receipts before you trust the diff.